So this video lesson deals specifically with how to convert a fraction to a decimal, why we might want to convert from fractions to decimals, taking you through the process, and of course giving you some examples at the end to practice on. So first let's consider what fractions and decimals are, because it's important to understand what they are and therefore why we can convert between them. Now a fraction we know is a number like 2/3, represents parts of a whole, it's still a number, represents perhaps a part of a whole, could be mixed, could be improper, but has a numerator set over a denominator with a fraction bar in between. So fractions are numerator, denominator, and they're often used to represent a unique part of a whole set. 2 out of 3 apples, 8 out of 12 pizza slices, etc. Now a decimal is also used to represent a part of a whole set, but it's based in our place value system. And therefore is based around tens, because our entire place value system is based around tens. So we have a decimal which is based on place value and breaks down information into tenths, hundredths, thousandths, 10,000ths, etc. And you can go on forever. The most important part, though, about fractions and decimals in this case is that they're both used to represent parts of a whole. They can be used to represent more than one, but more often the fractions themselves and the part that we call decimals, the tenths, hundredths, thousandths, 10,000ths, etc., are used to represent parts of a whole. And so if we look at some examples of fractions and decimals, specifically if we look at 1/2 and 5/10, they actually represent the exact same part. Talk about a half of a circle. And if we were to break down that same circle into tenths, not a particularly beautiful drawing, but it gets the point across. We can see that these represent the exact same amounts. And that is significant because if something in math represents the exact same thing, it means we can convert between them, or we have a way to change what is represented in one form to another form. Which brings us to the important part of this, which is the other meaning of the fraction bar. The fraction bar sets apart two numbers so that we know it represents a fraction. But the other meaning of the fraction bar, which is significant here and which is used sometimes in the order of operations, is divided by. So 1/2 also represents the same as 1 divided by 2. Because it means the same as divided by, we can set it up as a division problem. And if we can set it up as a division problem and we can divide it through, we can use decimal division and we can turn this fraction, 1/2, into a decimal. Now we know that the decimal version of 1/2 is 5/10. We said that before, but let's go ahead and go through this division and see what we mean. So 2 cannot divide evenly into 1 because 1 is less than 2, so we add a 0 here, we add the decimal point on top, and we have 2 divided into 10. Well, 2 divides evenly 5 times into 10. And we have a 0, and we're done. So, because we can go on with zeros forever, and all we get is 0.50000000000. You get the idea. So 1 divided by 2, which is the same as 1/2, which is the same as 5/10, or 0.5, but improperly called using place value, 5/10. Now that brings us to the important part of converting fractions to decimals. Remembering that that fraction bar just means divided by, all we have to do to convert a fraction to a decimal is divide the denominator into the numerator until the decimal either ends or repeats. Now here we're going to review two important parts of terminology for decimals. If you're unfamiliar with them, go ahead and look at the terminating and repeating decimals video lesson so you can become more familiar with them, or if you just need to brush up. But we have two different types of decimals, and in this vocabulary we have terminating decimals, decimals that end, decimals like 1/2, decimals like 1/4. We divide 4 into 1, goes twice into 10, 2, and then 5 times 2 goes into 20, and now we have a 0. We're left with only zeros left in our decimal and with a 0 remainder after a subtraction, so that means that this decimal has ended. 1/4 is the same as 25 hundredths. On the other hand, we have some decimals that are called repeating decimals, and those are decimals in which one or more of the digits repeats without end. And the most common example of that is something like 1/3. 1 divided by 3 3 goes into 10 3 times. Minus 9 is 1. Nx is 0, 10. Goes in 3 times. Minus 9 is 1. Nx is 0, 10. Goes in 3 times. Minus 9. We could be doing this forever. And in fact, we would be doing this forever because it never ends. 3 times 3 is never going to change. 3 will always go into 10 3 times with that remainder left of 1. And we'll just go on and on and on and on and on. 0.33333333333. Well, anytime that all we have left to do is annex zeros, and we've ended up at a place that we have been before in our division while annexing zeros. 10, 10, 10, 10. It's repeating over and over. That means the decimal is repeating. So we represent it with the repeating bar. 0.3 because that's the only digit that appears, and a bar over the 3 indicates that that 3 repeats without end. Now, if you need some review on how to find repeating decimals, a little bit more practice on identifying when decimals repeat, again, go ahead and look at the terminating and repeating decimals video lesson, and you'll have lots of practice for that. It goes into the idea of terminating and repeating decimals a bit more in depth. But assuming that you are solid with that, let's go through some example problems. Go ahead, there are 2 pages of these, so these are the first 2 problems. Go ahead and do these divisions. Convert these fractions to decimals and try to identify, is it a repeating decimal, is it a terminating decimal, and represent it as correctly as possible. Either it ends or by using the repeating bar. Well, if we look at 17/50ths, which is the example on the left, which I'll term number 1 and number 2, we have to be careful with our division. This is 17 divided by 50. Now 50 can't go immediately into 17, but 50 can go into 170. In fact, it goes in 3 times because 50 times 3 is 150. Drop that, another 0 becomes 200. 200 goes, 50 goes into 200 4 times, goes through, we get a 0. Now we're left with annexing zeros. We have a 0 as our remainder, so that means our decimal has ended. 17/50ths is the same as 34/100ths. Now for number 2, let's look at 10 divided by 27. Again, 10 divided by 27. Now 27 doesn't go into 10, so we need to add the decimal point and annex to 0. And 27 now goes into 100 3 times. 27 times 3 is 81. 100 minus 81 is 19. Now we're down to annexing a 0, and we're at 190. Now, 27 goes into 190 7 times. 7 times 7 is 49. 7 times 2 is 14, plus the 4 from the 49 is 18, and this becomes 190. Now we're at 0. Now we're at 1. We drop down to 0. Okay, we've got a 10. We can't do anything with it, so we add the 0 here. Drop down another 0. And now we're back to a familiar place, which is 100. We have seen this 100 before at a place where we're left with annexing zeros. That means we're now in a cycle. 0.370. Now we can go through this, and we'll go through this one more time just so you can see it. 3 minus 81 becomes 190. Adding another 0 down becomes 7 minus 189. Down to a 1. 10 can't go into 10, so you add a 0. Now we're back to 100 again. And we could go through this on and on and on and on and on and on and on, but we'd be at it forever because this decimal never ends. It repeats. In fact, it repeats all 3 of these digits. 0.370. Now that 0 at the end is important because it's a repeating decimal. If this were a terminating decimal, that 0 wouldn't be significant. But it is in this case because the 0 repeats along with the 3 and the 7. 0.370, 370, 370, 370. So we have to have the repeating bar there. And now let's take a look at the last 2 problems. 3 and 4. Go ahead, pause the video, look at those, and we'll come back and see how you did. So now we're looking at number 3, which is 2 and 7/30. For 2 and 7/30, we can leave the 2 out. We know the 2 is the whole number part. All we're looking at is converting the fraction. If we really wanted to convert it to an improper fraction, we'd still find that 2 is the whole number part. So let's just look at the 7 divided by 30. 30 dividing into 7. Can't go into 7, so we add the decimal place, and 30 goes into 70 twice. Subtracted is 60, minus that is 10. Drop a 0 is 100. Now this should start to look familiar. 3 times 30 is 90. 100. We drop another 0, and now we're back to the point of annexing zeros, and we've seen something that we've seen before. We're back to 100. That means that 3 repeats. Now this is significant. The 2 does not repeat. This is 0.23 with the 3 but not the 2 repeating. So we only put the repeating bar over the 3. Now looking at 1/7, this is 7 divided into 1. This is a long decimal, and so theoretically, if you went through it and got through it correctly, you were here for a little while dividing into it. This is a repeating decimal. It does repeat. It goes through a little bit, so let's go through and find out where it actually does repeat. This is 7 into 10 is 1, 7, 30. 7 into 30 goes 4 times for 28. Into becomes 20, to 20 twice, with 14 becomes 60. 7 times 8 is 56. 60 minus 56 is 40. 7 into 40 is 5 times, because we have that as 35, becomes 50. And now I'm going to write the 50 back up here just for the sake of space. Goes in 7 times, 49. We're back to 10. Now we're at the point of annexing zeros. We've seen a 10 before, and we have a 10 here. That means this entire set of numbers repeats. So 1/7, 0.14285, all with a repeating bar. So one more time, changing fractions to decimals, you divide the denominator into the numerator until the decimal ends or repeats. And if it repeats, you have to add the repeating bar.